All right, let's get set. Our next presentation this morning is on RDMA and virtualization. And I'd like to welcome both Liran Liss and Alex Neitz to present.
Thank you. So Alex and myself will both present this. I'll focus on the host stack of things, and Alex will focus on the network side. So the topic is RDMA virtualization. And we'll cover kind of our past experiences in the past couple of years regarding RDMA virtualization and why we think that it's time to have a more formal and standardized approach towards InfiniBand virtualization. And we'll cover then the impacts on OFS software that stem from these observations. So we'll start with virtualization today, and I kind of want to put this in like quotes, because today there is no standard InfiniBand virtualization. As a vendor, Mellanox does provide SRIOV support for InfiniBand for a couple of years now, but this support is device specific, and in this case we're talking about the ConnectX-3 device. And the way that we achieve that is that we basically have two inconsistent views of InfiniBand. On one hand, we have the network that is not aware at all of virtualization. Okay, it sees just a plain HCA. And on the other hand, we have virtual machines that access virtual functions that each of them thinks that it sees its own unique HCA. And someone needs to bridge the gap between these two views, and we've covered it here in this conference a couple of years ago. And the one that does that is this complex piece of para-virtualization logic that sits inside the PF driver. So this para-virtualization logic basically tunnels all the MADs to the different functions, and then it proxies those MADs to the SM when sending those to the wire on the real QP0 and QP1. And this proxying is not just a simple packet forwarding. It has to do a lot of stateful translations. For example, it has to guarantee unique transaction IDs. It has to multiplex GMPs depending on the class. For example, for incoming CM requests, we multiplex according to the GID that's embedded inside the payload. By the way, the identity of each of these functions is a GID. So all of them share the same lid because, again, we're not modifying the InfiniBand device. But what the trick we did here is basically we took advantage of the fact that in InfiniBand you have a GID table rather than a single GID entry. And then we use different indexes in the GID table as the identities of different functions. And we emulated this view so each function sees only a single entry GID table. But in practice, it's using some other index. So like VF2 might use index 17. And as an example for another complex handling is multicast management. So let's say that I have a first VF creating a membership record on multicast group A, and then I have a second one. If I send another membership request, then the SM is going to ignore it. But when the first one leaves, it's going to disconnect the second one because there is no notion of reference counting on membership records in the Subnet Manager. So the way we solve that is that the para-virtual logic kind of proxies these multicast memberships to the SM. So it will send only a single membership record request, and it will revoke the membership only when all or both of the functions have left the group. So it's kind of like what the Linux kernel does to multiple processes and applications. Instead of getting called by function calls, we get called by MADs. So in this case, when the second function joins the group, this pair of virtual logic is going to artificially generate a GMP response to that VF as if it was received from the SM. So in other words, this is a lot of complex code. It's vendor dependent. I mean, it practically sits inside the MLX4IB driver. And this whole notion is not visible to InfiniBand management. I mean, when you log into the, you look into the SM, you can't get a list of all the currently virtual machines that are currently, the host names of virtual machines that are logged into the fabric. You can't do partitioning, at least in terms of path queries and such, in terms of like visibility, because the SM is not aware of the partitions of each virtual function. We do guarantee security here. I mean, a VF cannot transmit packets on a partition that it hasn't been allowed to, but it's kind of a hybrid model. So looking into the future, we came up with a few requirements that we want to address virtualization, because this is gaining a lot of traction. HPC clouds is now a reality by multiple vendors, and people are looking for this, for this to be more robust and standardized. So the first thing we want to do is scalability. We do not want to increase the lid space by 3 orders of magnitude. We don't want to increase the SM overhead by 3 orders of magnitude. So we want the notion of managing the physical topology in the order of physical nodes and not virtual machines. We want to get full-blown management for virtual machines. I mean, partitions and identity and service records and multicast management. I mean, we want virtualization to be an equal citizen in the IB fabric. We want simplicity. We don't want any kind of software-to-software communication between VFs and PFs. I mean, why should a virtual machine depend on the current scheduling considerations of the hypervisor in order to, or the driver domain, depending on your hypervisor, to get feedback on some command or some operation that it does? We don't want this para-virtualization logic. And all of that, we want at the same time, we want to be backward compatible with the environment that we have today, both the SM and the different nodes and boxes and storage and whatever exists today in the InfiniBand ecosystem. So when we looked at the solution space of solving this problem, we came up with a couple of directions. The first is kind of obvious, means do nothing. I mean, just emulate a full-blown InfiniBand switch in your HCA. Behind that switch, you have a bunch of HCAs, which are virtual, but for every practical reason, they're HCAs. And this doesn't need any change, right? I mean, it's already defined. The problem is that it kind of misses the mark with regard to scalability and SM efficiency and lid space, and also it's really hard to implement for nothing. The second approach is, okay, let's have an IB switch, but an advanced switch that's, I don't know, it's simpler. You don't need to program its FDBs. I mean, because it's embedded, we can know the GIDs of the virtual machines directly. The SM doesn't need to program those. We're doing like kind of this GID forwarding instead of lid forwarding. But to be backward compatible, you have to still be a full-blown IB switch and then advertise a capability that says I can be managed more rapidly. But first you need to be a full-blown IB switch, and then again, I complicate the implementation considerably. So the third approach that we came up with is a virtual port array, which is basically, let's have just array of multiple virtual transport endpoints that share the same physical port. Now, this notion shouldn't come as a surprise to anyone here because it's already been done before in a couple of domains. The first one is SRIOV, where you have multiple functions, physical and virtual, sharing the same function space. And the second is fiber channel. With NPAV, I mean, you have your initial fabric login, and then you do a discovery, and you can obtain additional fiber channel IDs for your virtual HBAs. And those fiber channel IDs are equal citizens in the fiber channel fabric, right? You can do zoning, you can do loon masking, you can do whatever you want, while still sharing the same physical port. So basically, we want to do the same thing for InfiniBand. We want to have a notion of virtual transport endpoints that share the physical port, but enjoy the whole platform features of InfiniBand management. So on the figure here, basically, this is kind of what we want to achieve. So we have a channel adapter. It's a standard channel adapter. We have this virtual port array. And then we have a couple of virtual machines, and we have some TCA that let's say that we want to define a partition that includes VM1, VM2, and the TCA. So we want to be able to express that. So we want to have VM1 have an HCA that in its peaky table has only the green peaky, and the TCA has only the green peaky, and VM2 on the lower hand side also has the green peaky. That's it. So that's what we're aiming at. And we gave this initial, we gave an initial presentation about this concept a few weeks ago to the IBTA. It's only the initial engagement, so it'll take time until IBTA does its work, decides how to proceed on this, but we're going to follow it closely. So what we need to do, well, first of all, as IBTA progresses in inspecting these directions, we'll need to verify that indeed this model is accepted by them. And of course, there will be a lot of standardization efforts to get this. I mean, this is not a small concept, right? You need to define how packets are relayed between these virtual HCAs. You need to, might need some changes in verb semantics, I don't know. You need to define management models. You need to define MAD formats. All this is IBTA work, and currently I don't have nothing to tell you about that because it's not started yet, but hopefully it will. What I can do is basically say what we do anticipate from OFA if and when this direction matures. And this is based, first of all, on our previous work with ConnectX-3 on this emulated model, because essentially it's more or less the same thing, right? Because you have, even in this emulated model, we have all these functions sharing the same lid and same physical port, and each one is identified by a GID, right? So it's more or less the same model, but now we want to have these virtual functions being officially recognized by the subnet manager. That's the main difference. So there won't be any need for para-virtualization. So based on our experience with ConnectX-3, we came up with the following implications to OFA. So we'll talk about the device model, about what is actually this virtual port, how the OpenSM might configure HCAs that support this capability, host stack changes, some words and backward compatibility, and that's about it. So the device model looks like this. At the bottom, we have the two physical ports, if this is a multi-port HCA. Each physical port has this array of virtual ports, and then we have these virtual HCAs that are associated with virtual ports. Now, this association really doesn't concern InfiniBand management. All InfiniBand management needs to see is only the physical port and the notion that it has a VPort array. But in terms of what's happening, it looks like this. And I think that the main takeaway from this slide is we have each HCA has its own verbs handle. So it's a different device. Each has its own resource pools, its own QP namespace, its own CQ namespace, everything. It's a channel adapter that just happens to share the physical port. And again, since we're not changing the existing infrastructure, the existing models, as a whole, this HCA, this physical HCA is still a standard CA node, right? It has only a single port, a single SMA. So in this case, we're probably need to nominate one of the virtual ports to be the one that can actually send and receive packets from the SMA. at least as an initial concept. While QP1, GMP traffic can carry GRH, therefore we can uniquely identify and route traffic to individual virtual HCAs. So this is like at the high level.
So what characteristics do you think are going to be different about the view of the port from one virtual HCA? So for example, I think you mentioned peaking, so
Good question. Excellent question. Here what we think is a good start for virtual port properties. Basically, anything that's transport related. Everything that's link related is not. So it means each virtual port has its own GID table, PK table, logical link state, not a physical link state. Capability mask, counters just to be backward compatible. Okay, we don't want any change in the observable verbs interface. And probably the ability to invoke a client re-register on a specific virtual machine, while all the physical port stuff are just shared. So you can read them, but you can't modify them. In any case, in InfiniBand, you can't modify them.
Well, by having some independent tables here for the virtual ports, then will those be updated in a conventional fashion? So
Yeah.
the SM should be able to write each of them. So doesn't each of the virtual HCAs effectively use its own virtual version of 50?
No.
Target of
I'll let Alex cover that in what we envision of doing, but I hope that will be clear. So yeah, with that, I'll.
Okay, so as Liran said, here are the properties of the virtual ports. Some of them are unique to each VPort, to each virtual port, and some of them are shared between all the virtual ports based on the same physical port. From Subnet Management point of view, channel adapter should expose a capability bit telling the Subnet Manager that it supports virtualization. Subnet Manager in turn should query for this capability and enable virtualization on the physical ports. Actually, there's a main difference between physical ports and virtual ports in terms of that virtual ports are very dynamic in nature. They come and go more frequently than physical ports. Therefore, we need additional mechanisms to expose aggregate port state reporting to the Subnet Manager in case any of the state of the virtual ports on a physical port change. So it's done by some kind of trap. And for Subnet Manager, it needs a mechanism to collect the state of all VPorts at once to see which one are up or down. OpenSM, it's a critical resource in the network, and now it needs to be extended to support virtualization. Actually, we want to minimize the risk for virtual ports mechanisms to interrupt with current operation of the OpenSM, which basically configuration of the entire subnet and keeping the subnet administration. Therefore, we think that we need to divide the initialization stage of the fabric into two phases. During the first phase, OpenSM will do actually what it does right now, sweeps the fabric, discovers all the entities in the subnet with all their capabilities, configures leads, configures routing on the switches, and initializes the ports. At that point, it already should have the notion of which ports support virtualization and which are not. However, in this stage, it doesn't have aware of any virtual ports that are part of the fabric. After the heavy sweep ends, and during the idle queue, where SM is less busy with fabric configuration, it should go over all the discovered physical ports that support virtualization, discover the virtual ports above the physical ports, and configure all the relevant data for these virtual ports, for instance, the partition table. During the fabric maintenance, actually, right now, OpenSM periodically sweeps the fabric to see if there are some changes on the switches, or in case it receives a trap from the switches, it resweeps the fabric and keep up with all the changes that occurred. Same sort of thing should happen with the virtual ports. On one hand, we don't want OpenSM during the light sweep go over all the physical ports and collect information regarding the VPorts, because it means that OpenSM should cover the whole fabric during the light sweep. It's not desirable, so we think it's be better to rely on trap to be sent from the physical port in case any of the VPorts resides on this physical port, change its state, goes up or down. So after SM receives this trap, it can go and collect relevant information only from this physical port that reported a change and update its own database and configure new discovered virtual ports. Regarding Subnet Administration, there are some fundamental changes. First of all, like Liran mentioned, every GMPs must go out with GRH, otherwise they won't be able to be routed to the correct virtual ports. An additional change that's required is that the picky validation that's being done over physical picky tables over of the physical ports now should be done based on the picky tables on the VPorts. It means that if a virtual port sends some pass record query, SM should validate the request according to the its own picky table.
Okay, so that was more or less the like the subnet portion of tackling this concept. Let's talk a little bit about the host stack. So it turns out that the host stack is actually very simple. Basically, no changes are required. Only the semantics a little bit change, and the changes are as follows. Query device returns you the virtual HCA properties, not the physical HCA, all right? So you get your, I don't know, your maximum QP count of that virtual HCA. Query port returns the properties of your virtual port, your virtual port git table, picky table. I don't know if those are separate APIs, actually. Probably the port state is the most important thing. Asynchronous error and events, they pertain to the virtual HCA resources. Link states are referred to the virtual port states, and it's more or less for everything else. We don't think that we need to make this transparent to the host stack, because InfiniBand management is very explicit. And I think it's a good thing. We should probably maintain it that way. So, for example, that you're running over a virtual port or in the virtual HCA. You might not do anything interesting about it, and most applications probably won't care. If you want to know, you'll know. The ones that will want to know is probably the OpenSM and management utilities. But just applications, they don't know and don't care. A few words regarding backward compatibility. So I'll just briefly mention one option is to say that we can nominate one of these virtual ports as special in the sense that it kind of mirrors the git table and picky table of the physical port. So, and I assume that typically this would be the PF driver. So if you have, an SM that's virtualization unaware, doesn't enable this capability, and you have hosts that, I don't know, with some host stack that they do a path query, they get a hop count more than one, but they still don't use GRH. Why? I don't know, a bug. Okay, so at the bare minimum, your physical function driver is going to work, no matter what. It's going to work with old SMs, it's going to work with whatever you run on its own stack, it's going to work with whatever peers you want to interact with whatever embedded systems you're interacting with. The PF is going to work, point. If you want to work with virtual functions, then you need a virtualization-aware SM to start with. This doesn't mean that your peers need to be virtualization-aware. If your peers know how to interact with hop count more than one, then they will interact just fine with your virtual functions. No changes required. Complete interoperability. The final topic is hypervisor APIs. This is actually not related to IBTA and standardization, but it's more a Linux thing. We know that in virtualization systems, hypervisors like to control the identity of their virtual interfaces, whether their port state is up or down, quality of service maybe, and maybe resource utilization, because there's such a wide variance of a virtual HCA that can consume resources. So in our current vendor-specific implementation, we use this sysfs entries, which are, again, implemented in the vendor-specific code, which we would like to basically deprecate. And instead, we want to be more conformant with what Linux does with Ethernet virtualization, which is basically control network SRIOV through network interfaces. And it turns out that Linux is not the only one that does that. Also, Windows and VMware do exactly the same. So we want to do the same here. Basically want to use the base IP over IP interfaces of the physical function as kind of the entry point to control virtual functions. So some of these functions that are already defined in Linux work just fine for InfiniBand. For example, set VF rate, set VF link state. I mean, they apply just as well for InfiniBand links. And some of them we'll need to add new NDO functions for Linux, like setting the node GUID, the port GUID, maybe some limitation on the amount of resources that the VF can acquire, etc. But the idea is the same look and feel as Ethernet virtualization. We might even think of wrappers like maybe even supporting setMac. So if I get setMac, I'll use the RFC of modified EY64, extract the git out of that, and then program the git and node GUIDs appropriately, so I can run libvirt seamlessly without any changes over InfiniBand. An option to consider. But this is the idea. So in conclusion, we think that the time is ripe for RDMA virtualization. We're seeing increasing deployments of that. And as we move to more advanced devices and more advanced networks, we see a real need to make the network fully aware of virtualization. And we also see a need to get the implementations a lot more efficient. I mean, no need for this software-to-software interaction, which really causes dependencies. I mean, there are hypervisors in which the hypervisor is very weak. Not a lot of memory. Maybe it has a lot of other tasks or background tasks. We don't want VF functionality that when it opens a QP to depend on scheduling in the hypervisor. So this is probably one of the main reasons. Again, we started work with IBTA on this. It's going to take some time, but we'll follow it closely, and basically we'll try to adapt the implementation according to what IBTA does. And finally, from OFA, we have a lot of software involved in this. Okay, so we have some changes in the host stack, not a lot. As I said, we don't want to be invisible, so we want to expose the fact when you do IBV dev info, is virtual port? Yes. And virtual port statistics, here there are, and something like that. We want to have changing the OpenSM to be aware of this new concept and, of course, manipulate the proper MADs. And we probably want to also extend the management tools, like I can, with a single command, I don't know, do IBD discover and see the host names of all virtual machines that are currently online in the fabric. It's going to be neat. And yeah, that's it. Thank you. Yeah.
I just want to clarify that on the wire, there's no real changes. It's just the VPort just has a different git. All of this is in the sort of control plane, mainly Subnet Management, obviously.
Right. Right.
I have a follow-up question, which is for Rocky V2, if I analogize this, is the main workflow. One, the virtual, the VMs are identified by a unique IP address. The desktop IP address is how you're identifying the VM. And two, then all of this subnet management stuff goes away, and the main thing would be...
Yeah, I'll answer your question. Let me make a brief observation of Rocky. All this work applies only to InfiniBand. The nice thing about Rocky, that it's already there. You don't need to do anything. Because Rocky is basically, it's a transport over an Ethernet NetDev, and in Ethernet you have this embedded switches, that are working years ago, and basically they're out of the concept of management. So, Linux has new concepts, there are new flow steering and physical switch management. There are a lot that's happening right now in Linux regarding managing embedded switches, and it applies seamlessly to Rocky. Rocky is just another form of Ethernet packet. So the difference here is that in InfiniBand, the management of the subnet is explicit, right? It's standardized. You discover every node and you discover the virtual port, and the same assigns partitions. And in Ethernet, it's transparent bridging. So whatever works for Ethernet works for Rocky.
There's still some query device things that say I'm a virtual port or
Yeah.
virtual port. So that's what I'm saying. Most of the work, there's a lot less work for Rocky.
Yeah, there's no work for Rocky.
Do the virtual ports maintain the PMA counters? You got PMA counters for each virtual port?
Well, I expect to be completely 100% backward compatible. So the PMA counters for this CA node remain exactly the same with exactly the same semantics. What we expect is probably IBTA might define some counters that are specific to vPorts, which have counters that are meaningful for them. For example, byte and packet counts, but exclude stuff that are not meaningful for them, like errors.
All right, so you still have the physical PMA counters?
Yeah, and you see them. Inside your VM, you see the physical counters just the same because they're shared, and then you might query your vPort-specific counters.
Right, but that's not defined yet. You're envisaging that.
Yeah, it depends what the IBTA comes up with. Yeah. Thank you very much.